The first part of chapter 2 part 1 is the first order partial derivative. So here are the notations. If it is respect to x, the notation is del z over del x equal to del f over del x equal to fx. And if it is respect to y, the notation is del z over del y equal to del f over del y equal to fy. So next is the steps for function of two variables, fxy. For the first step is for fx, we hold y as a constant and find the derivative with respect to x. And for second step, for fy, we hold x as a constant and find the derivative with respect to y. We differentiate the equation function with respect to y. And then, if the question asks for the value of fx or fy, we just plug in the values of x and y in the function. Next is steps for function of three variables, which is fx, y, z. For the first step, for fx, it is the same, but with z, we hold y and z as a constant and find the derivative with respect to x. And the second step for fy, hold x and z as a constant and find the derivative with respect to y. And the third one for fz, hold y and x as a constant and find the derivative with respect to z. For the last part is partial derivative as a slope. So here is the example. The equation asks to find the slope of the line that parallel to the exact plane and tangent to the surface z equal to x times surd x plus y at point P, 1, 3 and 2. So the solution is here. The question asks for fx. So first we let u equal to x and let v equal to surd x plus y because we want to use the product rule for this question. So we will get x times with we differentiate v, which is surd x plus y, and plus with v times with we differentiate u, which is x. So we will get x times 1 over 2 times x plus y to the power of negative 1 over 2 times 1 plus 0, and plus with x plus y to the power of 1 over 2 times 1. We will get the answer x over 2 surd x plus y plus surd x plus y. So the question asks for the slope f at point fx 1 and 3. So we just plug in the value of x and y, which is 1 and 3. So we will get the answer 9 over 4.
Okay, so let's proceed to 2.2, which is higher order partial derivative. For the first one, we see fyx is displayed in the subscript notation, while for the second one, we see a partial symbol and is in the partial notation. And there's a technique while we see the subscript notation. Okay, so the technique is when we see the first one is y, the second one is x, means we differentiate with respect to y first, then only proceed to x. Okay, so here we can see there is the example and we will show in the next page. Okay, so now we proceed to the Euler theorem. Okay, as we can see here, when we differentiate with respect to x, then proceed to y, it will be the same as when we differentiate y, then x. So it will be the same answer as long as it is continuous and defined in an open space that contain a point A and B. Okay, so this example. Okay, so the example tell us to find that fxx, xy, yx, and yy. Okay, so let's see. The first one, we're instructed to find the fx. So we differentiate with respect to s first, then we differentiate again, so we will get the answer. Okay, so the second one, we differentiate with respect to x first, then we differentiate again with respect to y. Okay, so for the third one, we see yx, that means we differentiate with respect to y, then only x. Okay, so the last one is fyy. Okay, first we get the fy, then we differentiate again with respect to y, and then we will get the answer. So that's all from me. Thank you.
Next, I'm going to explain to how to find half derivative of composite function. Composite function is a function that have a lot of variables into it. For example, like this. Function of z dependent to the function of x and y, which is function of x and y dependent into function of t. So, if the question asks how to find the derivative of z into t, we use this general solution, or this is a kind of theorem. Also, we can make it like this type of root. For example, as I stated here. Now, how about the function with three variables? For like this function w that dependent into function of x, y, and z. Just add it more into the general solution like here. And this is the maps on how do we get the general solution. Next, what if two variables of each variable has another two variables? It is quite tricky, but we can still do it. For example, function of z dependent to function of u and v, and function of u and v dependent on function of x, y, and y. So, this is the general solution. If we want to get derivative of z into x, use this formula, while if we want to find derivative of z into y, use this formula. It's all dependent. It can be looked more clearly from this map.
Last but not least,
What if the question asks for more variables? For example, function w, which dependent on these three variables, and function of u dependent of another three variable, same as v and r. Same like uh, same like two variable and variable. You just use it like here. This is the general solution. That's all from me. Thank you.
Assalamualaikum and hi everyone. Okay, for the next part of chapter 2 of part 1, it is about implicit function. There are two ways we can express implicit function, which are function of two variables z is equal to fxy, and the other one is function of three variables, which is z is equal to f x, y, and z. Remember that for both functions, if and only if f x y is equal to 0 and f x y z is equal to 0, theorem 1 of function of two variables state that if f x y is equal to 0 defines y implicitly as a differentiable function of s, which is dy dx is equal to negative fs over fy. Theorem 2 of function of three variables state that if f, x, y, and z is equal to 0, implicitly defines a differentiable of function z as a function of variable x and y, which are delta z over delta x is equal to negative fx over fz. and delta z over delta y is equal to negative fy divided by fz. We use delta z over delta x and delta z over delta y in function of 3 variables just to make it different from function of 2 variables. And the picture below show that the example 1 is for function of 2 variables and for example 2 is for function of 3 variables. That's all.